Welcome back, mathematicians. In this video, we are going to look at the values of the trigonometric functions of any angle. At this point, you have likely worked with the trigonometric functions of acute angles, which means that the terminal side of angle theta would lie in quadrant number 1. But what we'd like to do is expand that to include quadrants 2, 3, and also 4. So let's let theta be any angle in standard position. As you might recall, standard position means that the vertex of the angle is on the origin, and that the initial side is coinciding with the positive x-axis. We're going to let x comma y denote the coordinates of any point except the origin 0, 0 on the terminal side of theta. So what we're going to do here is put the terminal side in any quadrant. I'm going to choose quadrant number 1, but I really could choose any quadrant, and here's angle theta. Now I'm going to pick a point on that terminal side except the origin and denote it as x comma y. If r is equal to the square root of the expression x squared plus y squared, quick time out, that is the Pythagorean theorem where instead of a, b, and c, you have x, y, and r, which is also representing the distance formula from the origin to the point x comma y, which is why we're letting r denote the distance from 0, 0 to the point x comma y. So from the origin here to this point here is a distance of r. Then the 6 trigonometric functions of angle theta are defined as follows. So here, our goal here is to transition away from labeling the ratios of our trigonometric functions to away from a, b, and c, or opposite, adjacent, and hypotenuse, into ratios where we are labeling the sides or the values of the ratio with x, y, and r. So in this case, we would say sine of angle theta is equal to y over r. Cosine of angle theta is equal to x over r. And tangent of angle theta is equal to y over x. Based on our reciprocal identities, we know that the cosecant of angle theta is equal to the reciprocal of sine, which means it's r over y, that the secant of angle theta is equal to the reciprocal of cosine, which is r over x, and finally the cotangent of angle theta is equal to the reciprocal of tangent, which is x over y. Now these are all true provided that no denominator equals 0. Now it's not possible for r to be 0, so in this case you'll never get a value for 0, a value of 0 for r, but you could have a value of 0 for x or y, which means that tangent, cosecant, secant, and cotangent of angle theta could be undefined. Now let's look at an example where we are being asked to find the exact value of each of the 6 trigonometric functions of a positive angle theta if 3, negative 4 is a point on its terminal side. Let's start by drawing the angle, and this is not a required process to draw it out. This is just something I like to do to make sense of the problem, to represent the information that we're given. Let's start with the vertex of the angle on the origin, the initial side on the positive x-axis, and identify where the terminal side of the angle would lie. That would be in quadrant number 4 because of the fact that 3, negative 4 also lies in quadrant number 4. This means the angle theta will be this angle here, and I know that because of the location of the terminal side, but also because it tells me that the rotation is going to be counterclockwise because of the fact that it is a positive angle. So I'm going to go ahead and identify the point on the terminal side as 3, negative 4. The next step in our process here is to go ahead and calculate the distance from the origin to that point. So that distance is going to be labeled as r, and so r is equal to the square root of the expression x squared plus y squared. Substituting the variables x and y with the values of 3 and negative 4. Remember, always use parentheses anytime you do substitution. So this would be 3 squared plus negative 4 squared. And so r is equal to 9 plus 16, which means r is equal to the square root of 25, which means r is equal to a value of 5. Now, let's talk about what you will get or what you could get for r and what you won't get. In this case, I got an integer. You could get an irrational number, meaning that you could get a value that is not an integer. It could be in terms of a radical, like, for example, square root of 20, which would be 2 radical 5. But what you won't get is 0 for r or a negative value for r. So now let's go ahead and identify our 6 trigonometric functions based on the fact that we know the value of x, y, and now also r. So sine of angle theta is equal to y over r, which would be negative 4 over 5. Cosine of angle theta is equal to x over r, which would be 3 over 5. And tangent of angle theta is equal to y over x, which is going to be negative 4 over 3. Then we do the reciprocal identities, and so cosecant of angle theta is equal to the reciprocal of sine, so that would be 5 over negative 4. Secant of angle theta is going to be the reciprocal of cosine, which would be 5 over 3. And then finally, cotangent of angle theta is going to be the reciprocal of tangent, which would be negative or 3 over negative 4. Now typically we would put the negatives either in front of the fraction or at the numerator. So for cosecant, it would more likely look like negative 5/4. For tangent, it would be negative 4/3 with a negative in front. And then sine, it would be negative 4 over 5 with a negative in front. All right, guys, good luck.